Look out, MATLAB, I just built the world's worst numerical programming language, and it's coming for your crown. This is I++, a super minimalistic numerical programming language that only has two constructs, functions, of course, and numbers, which are also functions, weirdly enough. We'll get back to that. Now, what the I++ language may lack in Google ability, it also lacks in usability because we're basing everything off of the combinator calculus using a single iota combinator as the basis for every single function. This is Turing complete. There's only one base function in the language. It's iota. Pretty cool, right? But it's written in Rust and there's a REPL online. That's pretty cool, right? But actually, the most unique feature about I++ is the fact that its math library is based entirely on Ojavoic composition. You remember that paper from like a month ago that found that every elementary function was creatable from just a single binary operator? Like this thing here. You remember that one? Yeah, so that's how all computation happens in I++. The number e can be represented as 1 of 1. So it is a two-tiered system. Numbers are combinators that can only be applied to other numbers. If you have a number applied to a regular computation combinator, that is a stuck term, which is fine. Anyway, our standard library is not quite finished yet, so we're going to write an advanced algorithm together called minus and plus. Okay? This is all we have so far. So according to the Ojavoic paper, this is how you would write minus, as ln of a applied to exp of b. But this is not syntactically valid because there's no named variables in our language. A and b cannot be passed in as parameters. We have to produce that with combinators. So I realized we could do this with a helper function that just swaps the parameters around like this. A, B, C, D goes to A, C, B, D, and then pass in ln and exp as the first two, and then we have the exact term that we want. How do we produce that helper function? I don't know, combinators suck. But going back to our standard library of combinators, there's a few things that look helpful. For example, C does this thing where it swaps the order of stuff. That's going to be really nice. And D does this thing where we swap the parentheses. Like surely if we combine those, we should get the right thing, right? Like here, it's literally two steps, right? A, B, C, D, apply the C combinator, we get A, C, B, D. Then on top of that, apply the D combinator and we get A, C, B, D, parenthesized. Perfect. What could go wrong? And if this was a stack-based language, that would be correct. We could just do that. Unfortunately, combinators suck so much more than stack-based languages. I didn't realize that, but they're so much worse. Because if we just run DC, ABCD, which seems like it would work and would work in a stack-based language, we actually get AD, BC, which is not what we were hoping for. Anyway, I think this is pretty fun. Go check it out at ipp.saxy.dev. Or the code is on Tangled if you want to contribute to the standard library. I'm slowly working my way up.